Okay, the last lesson we did algebraic expressions. This time we're going to do equations. They could have called this algebraic equations, but equations are a little different because it's got an equal sign in it. And what we're going to do is we're actually going to solve for x. In the last lesson, they told us what x, y, z, whatever the letters were. They told us what they were, and all we did was just plug them in and figure out what the answer was. This time, they're going to give us an equation, two sides with an equal sign in between, and we're going to actually find the missing variable. All right. Again, a very popular Algebra 1 topic. You probably did a ton of these, but we'll do it in here just so we get the practice, get the little refresher, get the summer cobwebs out of our head a little bit. So here's what they're going to tell you to do. They don't say evaluate this time. They actually say solve. And most of the time, they don't tell you what to solve for, because most of the time, at least in here anyway, they're just going to have one letter and you're just going to solve for that letter. Now, they may, let me just kind of flip through here. Don't think they do on this one. No, not on this lesson, but on later lessons, especially in Algebra 1, they may introduce a couple different variables in here, and we just have to solve for one of them, and then they would tell you which one to solve for. In these problems, all they're going to say is solve, and you just solve for whatever variable you have. Now, if you remember, I'm not going to teach this like it was a beginning pre-algebra, Algebra 1 class. I do expect you to remember a little bit, but I'll try to remind you of some things. We want to solve for x. We want to get x by itself. That's what we want to solve for. And so in order to solve for x, we need to get it by itself. In order to get it by itself, I want to look at all the stuff that's with it, that's on the same side. When I say the same side, I could put a little line in between the equal sign right here. I've got a left side and I have a right side. I know that some of you learned by putting this line right here and always working it out. And that's great for pre-algebra, maybe a little bit at the beginning of Algebra 1, but after a while you should kind of lose that line and just kind of mentally put that line right there that separates the left side and the right side. So what I want to do is I want to get rid of this 7. And it's not just a 7. Look in front of it. It's got a minus sign or a negative in front of it. I have to get rid of the negative and the 7 because that really is a negative 7. Well, how do I do that? In order to get rid of something, I need to do the opposite of what it's doing there. What is this thing doing? It's subtracting a 7. It's a minus 7. And so I have to do the opposite. Well, what's the opposite of subtraction? Well, that would be addition. And so in order to get rid of this, what I'm going to do is I'm going to add a 7. And that gets rid of it. How does it get rid of it? Because negative 7 plus 7 is a 0, and x plus 0 is x. And basically, I just got rid of the 7. Now in algebra, whatever you do to the left side, you could probably repeat this even without me saying it. Go ahead and try it. Whatever you do to the left side, you have to do what? That's right, you have to do it to the right side as well. So if I added a 7 to the left side, I add a 7 to the right side. So I'm not really changing the value of this expression at all. All I'm doing is moving stuff over, just moving it around, okay? Just taking it from the left side and just putting it on the right side. I like to work these up and down. Some teachers work these across, and I don't think that's a great idea. I think we should work these up and down like this. So what happens here? Negative 7 plus 7, they actually add up to a 0. Now, a lot of students love to say this, and I say this myself all the time too. We say that they cancel out, all right? But I want you to understand, because we're going to say cancel out for a lot of different things. Why do these cancel out? Because they add up to 0. X plus 0 is x. See that? I got rid of the negative 7 on the left-hand side. Bring down the equal sign, and then we work the right side. So I added a 7 to the left, and I'm also going to add a 7 to the right. So 16 plus 7 is 23, and I'm done. That's it. I solve for x. I have x by itself. That's what x is equal to. If I wanted to, I could plug it back into the original equation. Put in at 23 and for x. 23 minus 7 is 16. Yep, it works. So what do I always do to my answer? I always circle my answers. Again, just as a refresher, what did I do? I wrote the problem down, okay? I'm not just turning in a sheet of homework with a bunch of answers written on it. I write the problem down, I showed my step, I wrote the answer down, and I circled the answer. This is very important that you do it this way. Okay, let's do another one that's very, very close to that. This one, using different letters, it's m plus 12 equals negative 5. All right, let's look at it the same way. I want m by itself, so I have to get rid of that plus 12. Remember, if I put a line right there, I've got the left side and the right side. So on the left side, the side that's with the m, or the number that's with the n, is a 12. It's a positive 12. So how do I get rid of something? I do the opposite. So instead of adding a 12, which it's doing right here, how do I get rid of it? Now, if I added a 12, that's what a lot of students do. They put plus 12. But look what that did. If I put a plus 12, then I got a plus 24. I just made it worse. I didn't get rid of it, so I always do the opposite. The opposite of addition is subtraction. So I put minus 12 here, and I put a minus 12 over here. Put the line underneath, then I'm going to bring everything down. What happened to the positive 12 and negative 12? Well, they added up to 0, all right? A lot of kids like to say they canceled out, and that's okay, but I want you to understand why they canceled out. They added up to 0. So I bring down the m, and let's see what happens here. This is negative 5 minus 12. Some of you guys aren't so up on your addition and subtraction. So some of you guys would rather look at it like that, negative 5 minus 12. Well, what do you do for a subtraction problem? You add a line and you change a sign. Now, it's addition. You have the same sign, so the rule is you add them together. 5 and 12 is 17, and you keep the sign. So that would be negative 17. I would hope that many of you could just look at this, negative 5 minus 12, and figure out that it's negative 17 without using a calculator. Some of you guys need to do this, whatever it takes, all right? But you really need to get real quick at that, just like if it was just regular 5 plus 12. You should be able to figure that out. And it might take a little practice, extra practice on your own time and your own part. But anyway, that's why we're going through this right now. All right, let's skip part C. They have another one, but you can look at that. So that was A and B. I'll even label it. This is straight from the book. Again, you can follow along in the book, and I just skipped C. Let's jump down to the second example, and this is example 2, and it's letter A. So I'll tell you what, this is example 1, just so that you stay where I am, so you know how to follow along. This is example 2, and this is part A. This says 4D equals 36. Now, what's different about this compared to what we did up here? Well, if you look at what we did up here, you had something that was being subtracted. You had something that was being added. But what is that 4 doing to this D? Is it adding? No, because there's no plus sign in between. Is it subtracting? No, because there's no minus sign. It's actually being multiplied. Now, how did we get rid of the stuff up here? We always did the opposite. And so what's the opposite? 4 times D. What's the opposite of that, of multiplication? Well, that would be division. Now, how do we show division in algebra? For the most part, we show division with a little fraction. So I'm dividing by 4. Now, if I divided the left side by 4, I divide the right side by 4 as well. Now, remember, that's how we get rid of something. Remember we said that these canceled out, they added up to 0. Well, look right here. These don't add up to 0. 4 divided by 4 is not a 0. What is 4 divided by 4? Well, that's a 1. And that D is being multiplied by that 1. So really, I got rid of the 4. Because watch what happens. Okay, I know we say they cancel out, but why do they cancel out? This time they cancel out because it's division. 4 divided by 4 is 1. 1 times D is D. And then we do this division over here. 36 divided by 4. Don't just leave it like that. If it reduces, always reduce it. That goes exactly 9 times. And we circle our answer and we're finished. All right, let's try another one like this. This one's a little bit trickier. We'll call this B. This is a negative, and it's T over 8, and it equals negative 7. Let's scooch this up just a tad. To about right there is good. Okay, now let me go different colors so they stand out too. If I want to get the T right here by itself, so there's a couple things on the left side. You see the left side of this equal sign? There's a couple things over here that I want to get rid of. I want to get rid of the negative, and I also want to get rid of the 8. So you could think of this as a negative 8 down here on the bottom. So what is the 8 doing to the T? It's not subtracting, it's not adding, it's not even multiplying. What's it doing? What's that sign mean, that little fraction bar? It means it's dividing. So what's the opposite of dividing? The opposite of division is multiplication. So what I'm going to do is I'm going to multiply this side by an 8. And I'm going to put it over 1. All right, it's the same thing, just as a fraction, so we know 8's on top or 1's on the bottom. Now, this is not a minus. I should do this like that. Tell you what, let's do it like this, because that could be confusing with the minus right there. Let's do this. Let's put it on this side, just so, yeah, that looks a little bit better. Now, watch what happens. The 8's cancel out. They divide out to be a 1, but I'm still left with that negative. So instead of multiplying by just an 8, what if I multiplied by a negative 8? Why would I want to do that? Well, because look, this negative times this negative is going to be a positive, and then I've gotten rid of it. Would you agree? Negative times negative is positive, so really, look, the positive is just a positive t. What happened to the 8? The 8 canceled out, or divided out to be a 1, and what am I left with? I'm just left with a plain old positive t. That's what I want. Okay, I want just a positive variable. Get rid of the negative, get rid of the fraction, the thing on the bottom, and we're left with a positive t. Now, what am I going to have to do over here? If I multiply this side by a negative 8, remember this was a negative before we changed it. If we multiply this by a negative 8, I'm going to have to do the same thing over here. So I multiply this by a negative 8 as well. And you just do multiplication. Negative times negative is positive. 7 times 8 is 56. So t is equal to positive 56. Let's do another one. This does have a part C, and we're definitely going to do the part C on this one. All right, here's the problem. 3/5 x is equal to negative 8. All right. Let's see what color I'll use. I'll use this ugly brown color. Okay. What's going on here? Well, this 3/5, that's a fraction, right? This 3/5 is being multiplied by this variable x. It's being multiplied. So what's the inverse? What's the opposite of multiplication? Well, it's division. So you're probably thinking, oh, okay, well, I'll divide by a 3/5. Well, you could divide by a 3/5. All right, that's not wrong. But do you remember when you were a little kid, when you had, like, I don't know, I'm just making this up, if you had like 5/7 divided by 2/3, okay? This really, these numbers don't have anything to do with this. It's just kind of going back in time a little bit. But do you remember doing problems like this? You really never did a division problem when you worked with fractions. You always turned it into something else, didn't you? What'd you turn it into? You turned it into a multiplication. But we started with the first one. Instead of dividing by 2/3, do you remember? We multiplied by the, what's the word? Reciprocal. The reciprocal, or the inverse. I like to say reciprocal. So we multiplied by the reciprocal. What is the reciprocal? It's just flipping that fraction. This and this right here are the same exact thing, but we turn this multiplication into, we turn this division into a multiplication. But we can't just change it to a multiplication. We have to change something else as well. So we took this second fraction and we flipped it. It's the same thing as we're going to do over here. Instead of dividing by a 3/5, we're going to multiply by the reciprocal. What's the reciprocal of 3/5? It's 5/3. Look what happens. Look, the 5 on top, 5 on the bottom, they cancel. 3 on the bottom, 3 on the top, they cancel. And that's a nice, easy way to get rid of a fraction if it's being multiplied by a variable. So I'm going to do the same thing over here. Now these are going to cancel just like this. And then what do I do over here? I multiply by the same exact thing of 5/3. 5 on the top, 3 on the bottom. Now this doesn't have a denominator. Well, it really does though, because we could put this over 1 just to make things easier. See, these canceled out, so we're left with x. What can we do here? Does anything reduce here? No, not really. 3 doesn't go into 5. 3 doesn't go into 8. So we just multiply straight across. Negative 8 times 5 is negative 40. Over 1 times 3 is just 3. You just looked up here that nothing will reduce, and that's exactly how I would leave the answer. Okay, I wouldn't even try to make this into a mixed number. Okay, in algebra, it's probably better just to keep it an improper fraction. It's a lot easier to work with improper fractions than it is mixed numbers in algebra. There are times where it might be important, and I realize that when you're a kid, especially in elementary school, elementary teachers really harp on changing improper fractions into mixed numbers. But in algebra, I just think it's easier just to keep it like this, okay? And that's exactly, if you look in the book, that's exactly how they write the answer. And I would completely agree with them. All right, let's do a few more. Flip the page. I'm looking at P12 right now. So we've got about 3 more to do. And they're a little bit more involved. And that's how it always is, isn't it? Now, this is example 3. Let me scooch this down a little bit. This is example 3. They use a Q. Tell you what, my Q's are really ugly. You don't mind, do you? If I use an X instead of a Q, doesn't make any difference. Just because my Q's are weird. Probably everybody's Q's are weird looking. It's a weird looking letter, isn't it? All right, let's do this. What are we trying to do? We're trying to get X by itself. But now in those other problems, there was only one thing that was going on with this X. Okay, something was being multiplied by it, something was being divided by it, and that was it on those problems. Or in the beginning, something was being added or subtracted to it. In this case, there are 2 things that's going on. This 8 is being multiplied by the X, and this 15 is being subtracted from this whole 8X. So we have to get rid of both of those. We got to get rid of the 8, and we have to get rid of this minus 15 in order for the X to be by itself. Now, without going into a whole long thing, here's what I usually tell people. I usually tell people to get rid of what's being added or subtracted first, okay? Get rid of what's being added or subtracted first, then you can get rid of what's being multiplied. It's kind of like the opposite of order of operations, okay? We get rid of addition and subtraction before we get rid of multiplication and division, all right? So what's being added or subtracted? Well, the 15 is. The 15 is being subtracted. How do we get rid of a 15 if it's being subtracted? We do the opposite, which is add. So I add a 15. If I do that to the left side, I do that to the right side. Let's see what we get. This adds up to 0, doesn't it? Cancels out. Bring down this right here. I get an 8x. What about here? It's just addition. 49 plus 15. Say 9 and 5 is 14. That's a 5, and that's a 64. Okay? So now we're left with a problem. It's a very simple problem now, just like we had earlier. So all we have to do is get rid of the 8. What is that 8 doing to the x? It's being multiplied. How do we get rid of something like that? We divide. Divide both sides by 8. That cancels out, or divides out to be a 1, doesn't it? Okay. This cancels out, but it adds up to be a 0. These divide out to be a 1. We say cancel, but you're getting rid of them for 2 different reasons. So you bring down this, that's an x, and then 64 divided by 8 is 8. And there's your answer. You circle it, showed my work, wrote down the problem. Make sure you follow those steps. A couple more. This is part B to example 3. It's 12y plus 8 equals 6y minus 5. Now this is a little bit different than this one. On this one we only had one variable, one letter that we're trying to solve for. Over here, we have one letter, it's a y, but it shows up on both sides, doesn't it? You've got a y on the left side, a 12y, and you got a y on the right side, a 6y. You don't want them on both sides. You just want them on one side, like this right here. Once you get them on one side, then it's not that hard to get rid of all the other stuff with it. But you have to get the x or the y, whatever the variable is, you have to get it on the same side. So what are we going to do here? I could either bring this 6y over to the left side, and that would be okay. Or I could take the 12y and move it over to the right side. Okay, I could bring it to the left or the right. It doesn't make any difference. So you say, Mr. Hamrick, what do you suggest? Well, I'm glad you asked that question, because what I would do is I would take the smaller one and bring it over to the side with the larger one. And as you do these a little more often, you'll understand why. So let's look at this 6y. I don't want to just get rid of the 6 and move it over. I want to get rid of that whole entire 6y. So if you took a look at that whole entire term, what is that thing doing? What's the sign in front of it? It's a positive. It's a positive 6y. So really, It's being added to this -5. This is being added. How do you get rid of something that's being added? Well, you subtract it. You do the opposite of addition, which is subtraction. So watch very carefully. I subtract a 6y from both sides. Of course, I only subtract it from the other thing with a y. I wouldn't subtract it from the 8 because they would be unlike terms. I only subtract it from the term that has a y in it. All right, let's see what happens. Look, why did I subtract a 6y? Because they add up to 0. They cancel out. So I got rid of it on the right side, and I moved it over to the left side. 12y minus 6y is 6y. And let's do this. You could bring everything else down. A lot of teachers teach you that way, and if I was going to first teach Algebra 1 or pre-algebra, I'd probably do the same thing. But you've had some experience with algebra. So what I'm going to do in this situation, let's do this in a different color, I am going to get rid of this 8 and move it to the other side. Why do I want to get rid of the 8? Because it's on the side with the variable I'm trying to get by itself. So it's a positive 8, so I'm going to subtract an 8. That'll cancel out. So if I do that to the left side, I do that to the right side. I could have brought everything down and done the step right here, but I figure I get rid of two things in the same step. Get rid of the 6y in one step, get rid of the 8 in the other step. So positive 8 minus 8, it cancels out, adds up to a 0. Bring down the equal sign, and then let's figure out what this is. This is -5 minus 8. Well, -5 minus 8, add a line, change of sign, is -13. All right, hopefully that makes a little sense to you. Now, it's real simple now, because now I only have one variable. I just have one thing next to that variable. That's all I have to get rid of is that 6. It's being multiplied, so I divide by both sides. That cancels out or divides out to be a 1. Y equals, now, does 6 divide evenly into 13? No, it doesn't. So I can't reduce it. And again, it's an improper fraction, which is completely okay with me. I don't mind it being an improper fraction. So just keep it, -13/6, and just write your answer like that. I know it looks a little ugly. I know it doesn't make a lot of sense to keep your answer like that. But in algebra, that's what we're going to do. We're going to keep our answer just like that. All right, we have one more to do, and we'll be finished this lesson. Again, all these problems start off saying solve. So here's the problem. 3, then a parentheses, x minus 5 equals 13. Okay. All right, it's an x. We actually mentioned this word a little earlier. You have a number outside of this parentheses. This number 3 is being multiplied by everything inside the parentheses, and we have a little thing that we do, property. It's called a distributive property. We take that 3 and we multiply it by everything inside the parentheses. So that's what I'm going to do. Notice I can't subtract a 5 from an x, especially because I don't know what the x is. All right, so I can't do anything inside the parentheses. So what I can do is take that 3 and multiply it by everything inside of there. So let's do that. 3 times x is 3x. 3 times -5. Or you could look at it a couple ways. You could say 3 times -5 is -15, or you could just take that minus, put it right here, and say 3 times 5, which is 15, but you got the minus out in front. Either way, you get the same exact thing. I don't have to do anything to the right side. Now look, that's the only new step. This step right here, we did a couple examples ago, so let's do this quickly. I get rid of the -15 first. So I add a 15 to both sides. Remember, get rid of what's being added or subtracted first. That adds up to 0 or cancels out. Bring everything down. 3x equals 13 plus 15 is 28. We have to get x by itself. Get rid of the 3. It's being multiplied, so we divide both sides by a 3. That cancels out. X equals, does 3 go into 28? No, it doesn't. So I just keep it 28/3, and I'm perfectly fine. In fact, I prefer that you keep your answer 28/3. Don't try to change that into a mixed number, because all you can do to go from here to a mixed number is just make a mistake, all right? I mean, if you do change it correctly, then it's fine, but this would have been fine, all right? There's really no reason to change this to a mixed number. Just keep it improper, and that's perfectly fine, as long as it's reduced, okay? Make sure that it is reduced. If this was 27, let's say, 27 divided by 3 would be 9. That's the answer that I would expect you to write down. All right, well, I hope that made a little sense to you. There's a lot of problems on this one. I'm not going to have you do them all. So this is page P12. It's not page 12. It's page P12. It's chapter 0. Okay, so don't go to regular page 12. Go to page P12. And let's do this. Let's go 1 to 35, but we'll just do the odds. Number 1 to 35, and we'll only do the odds. All right, so that's saves you a little bit of work right there. I think doing it goes to 36. I think doing 36 problems a little overkill. I think you can learn how to do this stuff fine with these problems right here. All right, well, enjoy those. And if you have any questions, of course, the next day in class, we'll make sure that we can go over those. All right, take care.